This is section 3.8, derivatives of the inverse trig functions, page 1. So before we start working on those inverse trig functions, let's just talk about the derivative of an inverse first. So we're going to start right here with f of x is 3x plus 4 when x is greater than or equal to 0. Let's go ahead and sketch a graph. Shifted up 4 units. It's a parabola that opens upward. Like this. Uh-oh. This said for x greater than or equal to 0. So, can't have this piece over here. But now, more than that, I need you to think about why did I put that restriction on there. Before I erase this or white this out completely, do you see that this graph passes a vertical line test, but it will not pass a horizontal line test? So right now, this function does not have an inverse because we do not pass the horizontal line test. However, if I white this part out and just look at the part greater than or equal to 0, now this graph will pass a horizontal line test, and we can talk about finding an inverse. So, since we're talking about that, let's go ahead and find that inverse right over here. And do you remember, to find an inverse, we switch the x and the y so that this will say x equals 3y squared plus a 4. And then we'll solve for the new y. Subtract the 4. Is 3y squared. Divide out the 3. Take the square root of both sides. Okay, now, this says plus or minus, but we know we're not supposed to get 2 pieces out of this. That was not a function if we get 2 pieces out of here. So we need to figure out which one this is supposed to be. So we need to kind of think about this. Because x was greater than or equal to 0 on the original function, and we switch the x and the y for the inverse, then y has to be greater than 0 on the inverse. That looks funny, I'm just going to take that off. Then y has to be greater than or equal to 0 on the inverse. Y has to be positive. That means we need to take the positive square root. So the inverse is x minus 4 all over 3. Ugh. Okay, gotta let that dry first, then I'll come back and write it. X minus 4, there we go. X minus 4 all over 3. Alright, now, coming back and thinking about our original function, can you find f of 2? Sure, we just plug 2 into the original function, so f of 2 is going to be 3 times 2 squared plus a 4. 3 times 4 plus a 4, 12 plus 4 is 16. Okay, that means f of 2 is equal to 16. And would you agree with me that means that the point 2 comma 16 is on the graph of f of x? Okay, now come back over here to this inverse one, and let's find f inverse of 16. So we're going to evaluate the inverse function at 16. That's the square root of 16 minus 4 all over 3. square root of 12 over 3, square root 4, which is 2. So f inverse of 16 is equal to 2. That means then, like it did over here, that 16 comma 2 is on the graph of the inverse. All right. Now let's come here. Let's talk about their derivatives. So let's find the derivative of f of x. F prime of x, derivative here, just 6x. Nothing else to say, that's the derivative. Oh, maybe we could jump right down here and evaluate that derivative. So f prime of 2 is 6 times 2, which is 12. All right, now let's go back over here and let's find the derivative of the inverse. The derivative of the inverse. Well, first thing, let's rewrite that inverse as x minus 4 all over 3 to the half. Now let's do a derivative. Watch the notation. F inverse prime of x. All right, we have a chain rule going on, so we'll bring that half down. And then times the derivative of the inside. Now, yes, you could do quotient rule there, but it's much, much easier if you think of this as 1/3 x minus 4/3. Then you can see the derivative of that inside is just 1/3. And if we clean this up a bit, this is going to be 1 over 6 times the square root of x minus 4 all over 3. And we could get this square root 3 out of the denominator and just pull it up to the top. And that's going to be square root 3 over 6 square root x minus 4. That's the derivative of the inverse. And you can stop here. You don't have to rationalize out that nasty square root of x minus 4. You can leave it like that. All right, now let's go ahead and let's find the derivative of the inverse at 16. So we plug 16 into here, and that's going to give us square root 3 over 6 square root of 16 minus 4. Square root 3 over 6 square root 12. What's the square root of 12? 2 square root 3. So this is square root 3 over 6 times 2 square root 3. Oh, and look at this. These square root 3's divide out, and we are left with 1/12. Look at that. I wonder if it's coincidence or if that is supposed to do that. What do you think? Yes, it's supposed to do that. This 12 and this 1/12 are reciprocals. Okay, I took you through a whole bunch of work here today to get you to see this concept. Tune in for the next page as we write out this theorem and talk about how to use it.